Hello, everyone. In just a few moments, we will be ready to begin this exciting new event. In the meantime, as we usually do, I would like to remind you that you have access to our live chat, where you can interact directly and ask questions to our moderator. I would really encourage you to ask any questions you have. If necessary, I also want to remind you that at the very end of this presentation, I will provide you with a series of useful contact information that you can use to get in touch with us. Well, I would say that at this point we are ready to begin. First of all, please let me introduce myself. I am Massimo Baldessari, and I serve as the product manager at Allplan Italia. Right now, we will start this new event, which will thoroughly illustrate all the surveying techniques based on laser scanners and how to effectively generate our BIM model directly in Allplan from the point clouds that we will acquire today. As we will see, Allplan offers a comprehensive and versatile range of detailed, specific tools that vary depending on the specific surveying instrument that was previously used to carry out the site survey. Right away, we can see that we can immediately identify two main categories of instruments, the terrestrial instruments and the mobile instruments, which are essential for our analysis. Here is a comprehensive and detailed overview of the various topics we will be covering today. So we will go on to understand exactly what an MLS and a TLS laser scanner are, respectively a mobile laser scanner and a terrestrial laser scanner, and then look at the powerful solutions that Allplan offers to manage point clouds coming from these types of laser scanners, namely the innovative Scalypso for Allplan, Scalypso Mobile, and the Scalypso Modeler software packages. After that, we will look at their specific features. We will explore the characteristics of mobile point clouds and terrestrial ones extensively, while also providing a variety of practical examples on how to effectively use them to optimize our workflow directly within the Allplan environment. Let's start by analyzing the types of surveying instruments available on the market. As I mentioned, we have two main categories, terrestrial laser scanners and mobile laser scanners. From now on, these will be referred to as TLS and MLS. First of all, I need to ask myself which instrument I need, or at least from which type of instrument the point cloud should be derived. There are different types of situations. Now I need to specifically identify the types of work I am going to do. So here is where, if you mainly do architectural surveys rather than structural ones, cultural heritage, and so on, you will likely need very precise measurements. So in this case, I would start with a good TLS, meaning a good terrestrial instrument, which, if necessary, can be complemented by an MLS, so a mobile instrument that could be a drone or a system of the manual type. On the other hand, if the main focus of my daily work involves large areas such as roads, construction sites, and so on, then it is likely that the specific solution that best suits my needs is a mobile solution. So when exactly should I opt for the use of a stationary terrestrial laser? Well, it is mainly when I need an incredibly high level of precision that reaches down to the millimeter, and also when I am dealing with the specific nature of small to medium-sized projects where, quite clearly with a terrestrial instrument, I have to take into account the fact that I will need to carefully set up and then subsequently take down a tripod every time I move from one station to another. Simultaneously, I also need a terrestrial point cloud whenever I require an exceptionally dense cloud, which is especially ideal when I have to capture the existing conditions with extremely high precision and accuracy. On the other hand, you might ask yourself, when do I actually need an MLS, that is, a mobile laser scanning solution? It is best when I need to quickly survey vast outdoor areas or very intricate floor plans, essentially in those cases when the main priority is rapid data collection, productivity covering many square meters. Then mobile solutions, among many other things, become absolutely essential when I encounter significant difficulty accessing a certain specific area to survey it properly with a terrestrial instrument. The main reason I made this particular point is that clearly, depending on the specific instrument I choose to use, I will obtain different types of point clouds, and therefore I will always need to use the most appropriate tool for the job. In this brief summary table, I have tried to summarize exactly when it is better to use a terrestrial laser scanner and when it is better to use a mobile mapping system. For example, if I find that I need extremely high millimeter level precision for a project, I definitely get much better results by using a TLS. An MLS also gives me good results. But in this case, we're talking about centimeter level accuracy over very large areas, not just a few millimeters. On the other hand, if I am dealing with surveys of very large areas and need to capture them extremely quickly, a mobile solution is definitely more efficient than a terrestrial one. When it comes to the overall survey speed, for the very first time, it is indeed slower to survey a large area using a traditional terrestrial solution compared to using a modern mobile one. If I find that I need a very high density point cloud, TLS definitely provides me with a much denser cloud in terms of fine detail when compared to what I get from an MLS cloud. As far as georeferencing is concerned, everything for a terrestrial station is remarkably straightforward and easy to manage, thanks to the total station. On the other hand, a mobile station requires me to consider a variety of additional hardware devices, which must then be carefully calibrated and used to check the overall quality of my point cloud, depending on exactly which one is being used. Pusti. So, to summarize the situation, the common uses of a TLS solution are mainly related to monitoring the current state of buildings, whereas conversely, mobile solutions are undoubtedly best suited for vast areas and complex, extensive infrastructures such as roads, which are the primary focus of this specific type of surveying instrument. Now that we're finished with this brief introduction, let us take a closer look at the various solutions that Allplan offers to make the most effective use of point clouds coming from a mobile system and those coming from a terrestrial system. As for point clouds coming from mobile systems, and by mobile I mean, for example, a point cloud generated by a drone or by a mobile system that I have placed in my backpack, or even one that I hold in my hand, or others that are mounted directly on vehicles, the solutions that Allplan offers are called Scalypso for Allplan or Scalypso Mobile. These two solutions are designed to provide optimal management for all point clouds generated by mobile scanning devices. If, on the other hand, I have used a terrestrial device to generate my point cloud, it becomes necessary for me to utilize the specialized Scan Modeler tool. Scan Modeler is provided together with a dedicated tool called Scan Converter, which, as we will see in this demonstration, will efficiently convert my terrestrial point cloud into multiple point clouds that can be optimally and easily managed within the Scan Modeler environment. At this point, let's explore in more detail the various mobile MLS solutions available, specifically referring to point clouds that come directly from mobile devices. As I have previously mentioned in our discussion, Allplan offers two different solutions for this process. One is called Scalypso for Allplan and the other is called Scalypso Mobile. What is the main difference between these two solutions? The first allows me to load point clouds directly into Allplan in various formats, such as the standard E57, LS, TXT, ASC, PTS, and PLY. Looking at it from a different perspective, Calypso Mobile does not load the point cloud directly into Allplan. Instead, it loads it directly into this specialized tool called Calypso Mobile, utilizing the exact same formats we mentioned previously. This provides me with the opportunity and flexibility, thanks to an intuitive graphical interface, to manage which individual points, detailed polylines, or simplified point clouds I truly want to bring directly into Allplan. Therefore, I can decide exactly which specific parts of the point cloud are necessary for my workflow. So the very first solution available, Scalise for Allplan, imports the entire point cloud exactly as it is into Allplan, whereas the second option provides me with several additional management tools. Now let's look at terrestrial solutions. If the point cloud comes from a terrestrial laser scanning type of instrument, which is a stationary ground-based solution, Allplan specifically provides the Calypso Modeler tool. In the workflow designed for using this tool, what do I need to do? I will now use the powerful Calypso Converter tool to efficiently convert the most common point cloud file formats into a specialized format that can be read directly by Calypso Modeler. During this conversion phase, the point cloud will be partitioned and divided into n separate clouds. This will provide me with the capability, for example, in the case of complex buildings, to seamlessly and rapidly transition from one room to another, making all the navigation and inspection phases of individual spaces extremely simple and efficient. Once I have my point cloud directly inside Calypso Modeler, I will be able to perform a whole series of operations. I will have at my disposal a whole range of useful digital tools. For example, to take precise measurements, or I can choose to seamlessly transfer in real time individual points, polylines, or rooms. And by rooms, I mean the room entity available within Allplan, entire point clouds, simplified point clouds, or even single portions of point clouds. How exactly do I go about managing point clouds within the Allplan software environment? Essentially, I have three distinct types of elements that can be generated directly from a point cloud: detailed terrain points, complex three-dimensional polylines, and various types of proxy objects that represent the data. As we will see, the proxy object is an extremely interesting entity because it is extremely, high performing and therefore will allow me to handle very large amounts of data. Now let's take a closer look at what Calypso for Allplan does. Calypso for Allplan exports only point clouds as proxy objects into Allplan. On the other hand, Calypso Mobile and Calypso Modeler allow me to decide each time whether I want terrain points, 3D polylines, or proxy objects. When do I select one and when do I select the other? It depends. It depends on the context. Now, here I've tried to summarize the main use cases. I will typically use terrain data points whenever I need to create a digital terrain model, which is often referred to as a DTM. I will use 3D polylines when I need to export specific smaller portions of the model rather than entire models, primarily for performance reasons. Obviously, when dealing with a point cloud containing millions of points, it is simply unimaginable to import millions of individual polylines into your computer. Regardless of how powerful your hardware might be, it will never be able to handle that kind of load. On the other hand, proxy objects are ideal for importing very large point clouds. As we will see, it will be possible to import point clouds of over 100 million points directly into Allplan, thanks to this specialized technology called precisely proxy objects. Terrain points and proxy objects have a unique characteristic in that they are simply not able to be displayed or represented within section views. However, I am now going to demonstrate a technique that utilizes a TIFF image file, which will allow me to accurately section even the terrain points and various proxy objects. Before we proceed, it is important to consider the specific settings for this data. Where do I go to define how I want to directly import my points inside? In Allplan, before starting the transfer process, when I am clearly using either Calypso Mobile or Scan Modeler, I will definitely need to go into the Settings menu, which I can quickly access if needed with the GS key combination, and specifically define whether I want to import terrain points, 3D polylines, or proxy objects. So this specific type of operation must be carefully performed before starting the actual conversion and the subsequent transfer of the point cloud data from the Calypso solutions directly into Allplan. Now, at this point in the process, let's try to see how to best manage and organize MLS point clouds generated with mobile type laser scanning systems. And to do this, we'll start by exploring the Calypso for Allplan solution. So where exactly do I find it? Well, I find it directly within the Teamwork tab, and therefore the function specifically is Calypso for Adler. Once I activate this type of functionality, the options available to me are really simple. I need to select the folder where the file I want to import is located, and I can choose whether to keep the original colors or assign new colors to it. I can also effectively manage a possible project offset, and furthermore, I can decide whether I want to keep the point cloud density exactly as it is right now, or if I want to significantly reduce it. Here, as a practical example, I set a specific step value of 10, which helps me to slightly reduce the overall size of my point cloud data. I then start the import process. On the left, I have a plan view representation, while on the right, or vice versa, an animated type representation. Let's try to navigate the point cloud as usual, so I'll use the mouse. I can perform dynamic pans. I can do a whole series of operations. At this point, let's try to look at the concept of point cloud density. To do this, I have prepared a parallelly piped here in this area because this is the area where I want to intervene. At this point, what am I going to do with respect to this parallelly piped? I'm going to measure the minimum and maximum bounding coordinates. Afterwards, I will have the possibility to re-import the exact same point cloud data into the project. I will be specifying that I don't want to filter it at all and that I want to import it only and exclusively within this specific designated area. To achieve this, I have simply entered the precise minimum x, y, and z coordinates required for the selection. Now I will restart the import procedure again. And at this point, we will immediately and very clearly be able to see how the density of the point cloud is significantly more dense compared to the previous solution. This all becomes even more apparent thanks to the specific reference sheet that was placed there. Right here on the loan, let's take a closer look to see exactly how Calypso Mobile works in real time. Now, I am going to carefully import a massive point cloud consisting of over 120 million individual points. As you can clearly see here at the bottom of the screen, I will proceed to import them directly into Allplan as a proxy object, which is necessary precisely because we are dealing with such a very large and complex cloud dataset. And above all, a cloud that was generated directly by a drone. So let's look at the main steps. To begin the process, as a first step, I will need to inform the Allplan software that I intend to import that specific point cloud as a proxy object. This is a standard operation that you will likely find yourself needing to perform fairly often. Next, I will proceed to launch the Calypso mobile application. From within Calypso mobile, I will then import the entire point cloud directly into the Calypso mobile environment. Calypso on file. Once that process is complete, the resulting point cloud can be fully navigated. So for a specific example, I could easily identify my point cloud right here within this tree structure to check all of its detailed information, such as the total number of points. The point cloud can be navigated extremely easily, and if it is specifically needed for your project, with the professional help of Scalypso. On the mobile version, I have access to a wide range of useful tools, such as the ability to take precise measurements even before importing the point cloud data directly into Allplan. So here I can see, for example, that we have an excavation of about 25 meters. Moving forward to the next step, I can carefully identify and then isolate the specific area where I want to intervene. So I can decide which sector of the point cloud I want to export directly into Allplan. To do this, I have a number of options, such as the ability to manage the coloring of my point cloud. So if I want to capture the colors directly from my points, I can apply a step, for example, of 5 to reduce the amount of data. Remember, we're talking about more than 128 million points. As a matter of fact, even 128 million points can be handled effectively within Allplan. It is simply a matter of the transfer times within Allplan itself. At this point in the process, I have successfully imported my entire point cloud directly into Allplan. This comprehensive point cloud can now be fully navigated, and a very interesting aspect to consider is that in reality within Allplan we have simply imported 753 individual point blocks, the so-called proxy objects. So each of these individual items can be selected directly from the object palette or selected directly within the 3D model itself. The interesting thing to note here is that the points in my point cloud are snappable. Now, what does that mean for us? It means that, for example, if I wanted to take precise measurements, I can align with the points contained within these proxy objects. As a practical demonstration, for example, I could perform a precise measurement or place, say, a crane directly inside my digital model to verify if its placement is accurate. So once I've identified a specific point within my construction site and I've positioned my crane, I can then carefully decide if it's the most suitable position for example, lifting heavy loads. At the same time, I could also obtain further information from my model if I wanted to check, for example, the surface area of this terrace. All I would need to do is draw a series of 3D lines. Why am I using 3D lines and not directly a surface? This is primarily because of the fact that the specific points I am going to align probably do not necessarily all share the same z coordinate. So the unique ability to directly generate these sophisticated 3D lines, which can later be converted into a smooth surface thanks to the very practical patch function, allows you to effectively manage even incredibly complex surfaces. What can I do with this complex surface? For example, I could check its total area, and right here I find that it measures approximately 108 square meters of total exterior surface area. So I can take advantage of the point cloud to contextualize my project, or to start performing a whole series of operations right there inside my cloud environment. The closer I get to the model, the more clearly I can distinguish the individual points within my cloud. Now let's take a closer look at how, starting from a point cloud available within Scalypso Mobile, I can automatically generate accurate ground points directly within Alba. Once again, we're talking about a particularly dense cloud with roughly 97 million points that were originally captured using a high-resolution drone. And let's see how all of this is applied in Allplan. Now, for presentation purposes, I have divided the screen into two parts. On the left, we have Scalypso Mobile, and on the right, we have Allplan. Let's take a look at the characteristics of my point cloud to see how I can represent it with different types of colors. This type of color gradient is particularly interesting as it shows the various points at different Z elevations, ranging from blue up to red. As mentioned, we have 97 million points, and in this case, I have already imported proxy type objects directly into Allplan. Now, what can I do? For example, I can manually select a series of points that are relevant to me for carrying out various tasks on the riverbed of this river. Following that process, with this feature, I can directly export the specific terrain points. In this particular scenario we're talking about only 9 terrain points, which I can very easily query them directly from the object palette. Let's try deleting these 9 points that we just imported. Then we'll also completely remove those elements from Calypso Mobile. Let's navigate over to the specific Allplan settings and clearly indicate that we want to import the terrain points. Now, at this stage of the process, I'll use the export feature for my point cloud once again, and then I will define a designated area of intervention for the project. So now I will simply define a new polygon, and right here it is. And once I have completed this step, I will then decide exactly how I want to export my points directly. In this specific case, since these are terrain points, I can easily use a very large step value for the process. Here, for example, if I set a value of 200, considering this is a massive point cloud with over 90 million points, what exactly happens? What happens is that within the Allplan software, I have generated 2,595 terrain points, which I can now quickly identify within the previously imported proxy point cloud. What can I do with these terrain points? I could aggregate these elements directly within a DTM. So now I will proceed to generate a brand new digital terrain surface directly, which for now is still empty, being devoid of any data points at this stage. And to this newly created terrain surface, I will now add all of my individual terrain points. How? I will simply select all of these specific points with a selection window or conveniently by using the Ctrl key. By pressing A on the keyboard, at this point we have successfully and seamlessly integrated all those points directly into my terrain surface. All I need to do now is simply recalculate and update the display style, and there it is, a complete digital terrain model. This digital terrain model can, if it is necessary, be further optimized and refined, for example, regarding the triangulation along the outer edges. So, if I switch over to an animated view, I can see how, in just a remarkably short amount of time, I have created the entire surface of my terrain. Everything becomes even easier to appreciate when I re-enable the display of the proxy objects. As we can clearly see, there is an excellent overlap between the generated road model of the terrain and my original point cloud. If it becomes necessary, I can make a specific decision each time whether the step I use for exporting my point cloud should be increased or alternatively decreased. For this next part, let us take a closer look at a detailed example of using Calypso Mobile combined with the powerful ability to directly import 3D polylines into Allplan. In this specific case, we are talking about a building structure and a point cloud that isn't very dense. It is a total of 35 million points, and we will see exactly how to reconstruct small portions of my model and then seamlessly reproduce those specific elements directly in Allplan. In this situation, I will definitely need to select the three-dimensional polyline import mode. So, let's take a moment to look at the workflow once again. We have Calypso Mobile on the left side and Allplan on the right. Now I am going to move around, carefully navigating within the point cloud until I find some suitable reference points. In this case, I need to measure the floor-to-floor heights of my model. To do this, I place a point in this area. Why do I place a point? Because by doing so, I can capture its x, y, and z coordinates. After completing this process, I can specify that relative to the orientation of the y-plane, I want to generate a detailed cross-section view exactly at that point. I will be able to manage the density of my point cloud and then define an epsilon range, which is essentially a kind of slice. In other words, I won't be exporting a flat section of my model, but rather a slice. So we will have established and configured the import process directly within Allplan in the form of 3D polylines. And thus I will be able to see that my model has been precisely sectioned exactly in that area. This becomes even more evident when I proceed to generate a detailed cross-section from the 3D polylines we exported earlier. So I generate a section of my newly imported model, then I zoom in closely, and at this point, what can I actually do with this kind of result? I can use this tool, for example, to take precise measurements and realize that on the ground floor we have a floor-to-floor height of exactly 3.60 meters, whereas on the first floor we have a floor-to-floor height of 3.00 meters. Let's try to do the same operation on the second floor to find the same value, which is 3 meters. At this point, I can move this type of drawing to another document. Or if necessary, I can also delete it. Now I am going back directly into the Calypso mobile point cloud environment because I want to start creating a detailed floor plan for the ground floor, specifically focusing on the reception area. To do this, I will move around within my point cloud data to identify and select a specific reference point for the layout. Of this point, I have the ability to immediately see the coordinates. In this case, I'm interested in the z coordinate, which is about half a meter. So I move into the sections and tell Calypso Mobile that I want to select my model at this precise elevation. Once again, I will define a step. In this case, I can make my point cloud denser directly within Allplan. And once again, I set an epsilon range of 10 centimeters, so we will have an overall slice of 20 centimeters. Before I start tracing over my point cloud, I will define my floor-to-floor height, which, if you remember, was 3.60 meters. Now I move in much closer and more directly to my point cloud and then use the conventional Allplan tools to carefully and literally trace over these 3D polylines that we imported. So I go on to define a series of specific components. Here we've created our first two walls. Then from the point cloud, I notice that there is a noticeable and significant change in the overall thickness, so I will delete a portion of the wall and, for example, modify the thickness of the second wall using its properties. Or with other tools, I will reconnect this wall to the previous one, and maybe we'll add an opening. This is a small example of how I can use my section to reproduce my model. Here we've only created a few components, but clearly using the same methodology, you can go on to completely reconstruct the entire architectural model from scratch. Now I'd like to demonstrate for you some practical examples of using proxy point clouds within Allplan, and how, for example, you can efficiently and rapidly generate a series of sections to then use for reconstructing the model itself. Let's examine in more detail the concept of a proxy object as it is applied to architectural building structures. Let's go back to the example we saw earlier. Here, I have already imported my proxy cloud into Allplan, a cloud that can come from Calypso for Allplan or from Calypso Mobile. And so I can navigate through the entire project completely using the specialized tools that Allplan provides directly, Now let's suppose for a moment that we want to reconstruct this specific staircase that we see right here in the center. How can I do that? So for step one, I created a classic section without extracting it yet. Or rather, if I were to go and try to extract this specific type of section, what happens? Well, what happens is that I simply don't get any kind of result at all. Now, why is that? Because the proxy object is an extremely lightweight object. Let's say it's not actually a real entity, and so it cannot be represented directly within my point cloud. At the same time, I can use my section to navigate through my point cloud in this way by directly calling up the section. Or even better, I can call up my section perpendicularly. All you need to do is click on the right end of my section's name. At this point, what can I do from here? I can go ahead and perform a whole series of measurements since the points in the point cloud are physically present, and as a result, I can, for example, measure the height of my staircase or the width of my tread. Okay? Now, to make this process even more effective and simple, I could easily freeze exactly what I see here on the screen by saving everything as a static image. This image can be of exceptionally high quality by selecting much higher values in terms of the DPI settings. But the key thing is to remember to save this specific image as a TIFF type image file. Why is that the case? Because when I save an image as a TIFF, I also save specific metadata within it. What exactly are these metadata for? When I import that newly generated image back into the software, it will automatically be scaled and georeferenced to the correct coordinates. In other words, if I click directly on the individual pixels of my image, I will get the exact same results as before when we selected actual points in the 3D space. At this point, what do I do with my image? I can use it as a reliable reference system, for example, to help me reconstruct my staircase with high precision. All I really need to do is carefully define a few specific parameters, such as the total height of my staircase, the exact number of steps I need, and the overall length of my landing. Then I can simply align myself with the reference image shown above to very quickly and accurately recreate my entire staircase. So in a very short amount of time, I have successfully created my staircase, which as usual, I can now enrich with a whole series of intricate details, such as railings on both the left and right sides that accurately reflect the information coming directly from my point cloud data. This very same architectural technique used to reproduce the staircase can also be used to faithfully recreate each of the individual floors of my building. How exactly can we do this? To achieve this, it is sufficient to generate a series of horizontal sections, detailed sections that cut through my model at the specific vertical elevations that I prefer, in order to clearly identify each time the ground floor, the first floor, and so on. So directly from the animated window of my point cloud, I could bring up and visualize the second floor. Here, among other things, you can also clearly see and appreciate all of the interior furnishings. At this point, once again, the most effective and efficient solution available is to use and directly recall the point cloud by clicking the symbol at the far right of the name of my section, because it gives me a perfectly aligned and direct view of my model perpendicular to my section. So now I can directly export and save out this portion of the model specifically as a TIFF image, save all of my current work, and at this point import that same image back into the project so I can carefully trace over it for the next steps. Now temporarily, I'm going to turn off all the objects I have on screen, open the folder where I saved my image, import it, and once again, this type of image will be scaled and georeferenced. Following that process, I could use the standard and familiar Allplan commands, such as columns or walls, to carefully reconstruct the portion of the model I'm interested in. In this specific case, I'll need to completely flip the orientation of my wall. So I'll go ahead and place my wall directly up to this point, then create another section in this other area over here. And I'll either recreate or directly copy the wall I just generated. At this other point, and then I'll carefully cut through the upper wall so that I can get the specific section of the model I'm interested in for this project. Now I want to show you something that I find very interesting. If I display the point cloud again, you can see that on one side the image is geo-referenced and on the other it's scaled. What does that mean? It means that when I recall the entire point cloud with those few elements I've just reconstructed, those objects will be correctly positioned in the location where they were detected. Now, let's take a look at the use of proxy objects as they are applied to a large-scale infrastructure project. The infrastructure in this case is a railway tunnel that was carefully surveyed using a high-precision mobile scanning device and was subsequently imported directly into the Allplan software. So let's take a look at the Scalypso mobile solution, which was used to directly read this large point cloud of 18 million points. Once again, I can check my point cloud from several different perspectives. In this case, it is a reflectance cloud. Here it is. Thank you very much for watching. That's why you see it in black and white mode. Subsequently, once I have successfully generated my proxy objects directly within the Allplan environment, I then went on to create a whole comprehensive series of detailed sections that I can very quickly and easily recall in this specific way. Afterwards, directly from the active animation window, I could save the final result of the window as a high-quality image. This involves possibly adjusting the specific number of pixels I want to use for the output, and once again saving absolutely everything as a professional .tiff file format. Immediately following those steps, I can proceed to directly import my image into the system, which will then be automatically geo-referenced and perfectly scaled based on the actual physical measurements. So we have imported our image. In this case, for the sake of convenience, I will explain it. Go ahead and shift this slightly further down. Once that is done, I can also begin to manipulate my image by making the background completely transparent, and then I will be able to carefully and precisely trace the details directly over the top of my image to obtain all of the specific information that I need for this project. To draw a parallel, let's see what happens if I directly measure the actual points. Thank you. I am focusing on the proxy cloud rather than the pixels of my image. As you can see here, the height of my gallery remains the same. At this point, thanks to those types of objects, I have generated a series of curved and linear objects. Based on these, I created my model using the solid modeling features of Allplan. Here, I am directly overlaying it with the previously imported proxy cloud. So, the highly effective method of exporting as TIF images turns out to be an exceptionally convenient and efficient workflow for extracting every single piece of detailed information I need directly from a proxy type point cloud. Let's see how to effectively manage and organize TLS point clouds. That is, point clouds that have been captured using terrestrial laser scanners. For this specific purpose, we will utilize the advanced features of Scalypso Modeler. Navigating through these TLS point clouds within Scalypso Modeler is something that is extremely practical for your workflow. What exactly do I mean by that? Well, as you can clearly see in the tree structure on the left side of the screen, we have multiple individual point clouds, each corresponding to a specific scan taken by my station. So all of these various point clouds can, on one hand, be efficiently organized and categorized into convenient folders and subfolders. And on the other hand, they allow me to literally jump, for example, from one room to another. by simply and easily selecting the specific scans directly within the tree structure, or by selecting them in this navigation area, which is known as the scan radar, or even by performing a double click directly on the markers that we see right here within the point cloud itself. Once again, among other things, this point cloud is particularly interesting because we have a whole series of reflectance point clouds for the interiors in order to obtain more detailed information directly from my survey, and at the same time we have color point clouds on the other hand for all the parts related to the exterior of my building. When we talk about building surveys, the possibility of having a TLS type point cloud, that is, a cloud generated directly with a terrestrial station, has several advantages. One of these is the fact that I can manage it directly within Calypso Modeler. On one hand, as we have already seen, I can navigate my point cloud in an extremely simple way. At the same time, Calypso Modeler gives me the possibility to export the data directly into Allplan using a multitude of techniques, the ones we've already seen before, but also and above all in the form of rooms. Now, I'll show you a small example. We are now inside the Calypso Modeler interface on the left, so I can directly navigate through my room, specifically my living room area. Next, within the Allplan interface, I first select the specific proxy import mode for the proxy object. Why do I do this? Because it allows us to make a much more manageable file size while we are working on the project. For the sake of parallelism, I would like to go ahead and directly import a specific section of my model. In this case, I will use a very high epsilon range, a distance of 1.5 meters, starting from a height of 1 meter. I will carefully isolate only and exclusively the point clouds that are directly related to my living room, in order to reproduce the point cloud exactly as it currently exists directly inside Albla. Next, I will perform this type of operation. Thanks to this handy measurement tool, I will identify 2 points on each side of my room. Here in the corner, we have a pillar, so I will place 2 points on each side of my pillar. Now I will select the points that are most easily accessible and that define the direct dimensions of my space. Afterwards, I can tell Allplan to export these points as rooms, setting their height to exactly 1.5 meters. Now I have successfully exported the room entity directly into Allplan. To better appreciate everything, I will temporarily turn off the display of proxy objects so that you can clearly see the presence of my room. Actually, my room is much more complex. That's why it was necessary to move the tripod of the terrestrial instrument to create more point clouds in this corner. Here, in this specific case, among other things, I am displaying 2 point clouds. In a moment, you'll understand why. So I start with the technique we saw earlier. So I go and mark 2 points on each side, right? Here, 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 and here. And now I realize that I have a blind corner. No problem. I have another scan with respect to which I can identify that side that was blind in the initial survey. So I go and carefully place these final 2 remaining points, and at this point I can execute the exact same procedure as before. I want to export all my points at a fixed height of 1.5 meters, transforming them directly and seamlessly into a room. At this point, we can clearly see how the 2 rooms are perfectly adjacent to one another, and so I can also merge them directly together. Once I have my completed room, what exactly can I do with it? I can perform a wide variety of different operations, such as labeling it, measuring it, or even constructing the structural walls around the room itself. But the truly fascinating aspect that you should note is the incredible level of speed with which I surveyed my room directly, and then subsequently generated the entire detailed model. To be perfectly fair, this specific model was generated directly by our client. Here you can clearly see the import of the entire point cloud as a detailed proxy object. Right here, you can see a detailed overlay of the reconstructed model combined with the point cloud. And now, here is the exact same model sectioned, where once again we create this specific kind of overlay between the original cloud and the newly surveyed model. And here we see the model without the representation of the proxy point cloud. So let's move on to the final conclusions. Essentially, the main goal of this event was to explain in detail the difference between a cloud generated directly with a terrestrial type instrument and a cloud generated using a mobile type instrument. So, depending on the origin of my point cloud data, I will first have to decide which of the various Allplan solutions is most appropriate to use. For instance, I will choose to use Calypso Modeler when I have a high-resolution terrestrial type point cloud available for my project. Conversely, I will instead use Calypso for Allplan or Calypso Mobile when I have a mobile type point cloud available for processing. If your professional work is mainly focused on surveying complex buildings, and by buildings I mean both the detailed interiors and the expansive exteriors, the best suggestion is to use a mobile mapping system to quickly capture the entire volume of the structure. Then you should supplement that data with a series of high-resolution terrestrial scans at critical points where detailed precision is absolutely needed. So, if you have a comprehensive set of terrestrial type point clouds available, you will certainly make the best use of the advanced features provided by Calypso Modeler. Conversely, when you need to manage point clouds generated with mobile type instruments, you will definitely need to use the specialized Calypso for Allplan solutions or the Calypso mobile software package. Well, today's event has come to an end. Here you can discover a whole series of useful contact addresses that you can use to get further detailed information about all the Allplan solutions. Please don't forget to follow us on all our social media channels. Now I thank you for your attention and hope to see you at the next event. Goodbye, everyone.